section 4.5 today. We'll wrap this up. I am going to give you some homework today. We will come back Monday and do a little more practice with this stuff. And then we are going to take a couple review days and then plan on test next Thursday before we go into Thanksgiving break. So we were solving log equations yesterday. And the problems we were looking at yesterday, we were adding a log into a problem because we had an exponential where we couldn't get a common base. So today's problems are going to be a little bit different. They're going to start with a log in them. So think about how we got to the problems yesterday. We added a log, we brought down their exponents and solved from there. So if I'm going to undo this one, what should I do first? What's that 2 in front going to do? It's an exponent. So I could take that back to the exponent. So we know that it's legal to add a log on each side. It's true in reverse. If there's a log on each side, we can take it away. It has to be just one log on each side. And then we could drop those. So we can drop log base 5 and say x squared equals 9. So then how would we solve for x? Square root. When you add a square root, you have to do plus and minus. So we actually get positive and negative 3. But one thing we need to do on these that we have not had to do on all of our problems, we have to check. I've told you that with a log, the base and the argument both have to be positives. So my base is positive 5, my argument here is x. So can x equal negative 3? No. So positive 3 is my only answer. Is that one okay? Let's do this one.
Band and choir students need to report to the gym at this time. Band and choir students to the gym at this time.
Let me hear you sing.
Huh?
Let me hear you sing.
I can't.
I can play the saxophone for you.
Okay. So this one's different. How? Yeah, I have both logs on the same side.
Our school teachers will be dismissing to the assembly at 1:50 today. At 1:50 today, so keep all the students in your classroom until 1:50. Thank you.
I'm going to use every minute. So on this one, I had, oops, I didn't do that one. On this one, we had 2 terms and they both had a log. So on this one, not only do I have 2 logs on this side, but I also have a 1 out here that doesn't have a log at all. Think about your properties of logs. If your logs are added, how can you put them together? Multiply. So I have to take x plus 6 times x plus 2. Can I go ahead and FOIL that? So I get x squared plus 8x plus 12. Everybody with me? So I can't just drop the log and make it disappear because I don't have one on each side. But think about your definition. We've solved problems involving logs before by changing them into exponential form. So that would still work. So 5 to the first equals x squared plus 8x plus 12. So if we subtract over the 5, and then factor, what multiplies to 7 and adds to 8? 7 and 1. So if I set each of those equal to 0, I get x to be negative 7 and negative 1. But what do we have to remember to do on these? Check. It's not that x itself can't be negative, it's the argument can't be negative. So negative 7 plus 6, is that okay? No, that would be a negative number, so negative 7 won't work. Negative 1 plus 6 is positive, negative 1 plus 2 is positive, so negative 1 is the only answer that works. So if both sides have a log, we can just drop them. If only one side has a log, we have to change it to exponential form to solve. Let's do this one. So our first goal, if we have multiple logs, we need to condense them. What would I do with this 3? Mix it the exponent. If these logs are subtracted, how do you put them together? Divide. You get log base 2 of x minus 1 cubed over 4 equals 5. Okay, now what?
Multiply by 4.
We can't yet. We are going to do that, but we have to get rid of that log first. If it's only on one side, what did we do last time? We changed, yeah, change it to exponential. So 2 to the 5th equals x minus 1 cubed over 4. So 2 to the 5th is 32. So we can multiply our 4 now. Hold on. I made a mistake, didn't I? I wrote 35, not 32. What would you do now to get rid of your, or to get to the x? Cube root. Since it's an odd root, you don't have to do a plus and minus. Cube root of 128. Does it work out nicely? Now, I'm just going to leave it. I'm going to change this into a decimal at the very end anyway. So you could reduce the radical, and that would also be okay. What's our final step going to be? Add the 1 over. So we have the cube root of 128 plus 1. Yesterday we kind of got in the habit of giving these as decimal answers, so let's just go ahead and give this as a decimal answer. We get 6.0397. So far, so good. Let's try this one. So I have a problem. Over here, I have just a number and then a log. Do we have any properties for combining those? No. So what should I do? If we add a log, we'd have to add another log to everything. So that would actually make more difficult. What was the other option? Okay, what if we subtract this log over? If these logs are subtracted, what can we now do? Yeah, just what we did in the last one, combine them, so if logs are subtracted, we divide. And when there's only a log on one side, we change it to exponential. If there's no base written, what is it? 10. So it's 10 to the first equals 2x plus 1 over x minus 2. So I can multiply over my x minus 2. So I get 10x minus 20 equals 2x plus 1. So I can subtract over the 2x, add the 20. And so x is 21 over 8. I failed to do this on the last one, but what should I be making sure at the end of every one of these? Check them. You don't necessarily, I mean, you certainly can plug them in your calculator, make sure it works out, but at the very least you need to make sure your argument is positive when you plug these in. 21 over 8, if I'm adding to it, that's fine. 21 over 8 minus 2, that's still positive, so this does work. What if you plugged it in and it gave you negatives? No solution. If we only have one answer and it doesn't work, it's just no solution. And that is possible on these. Let's try maybe one or two more, and then you guys can try some on your own and ask me questions. Let's do this one. What do you notice about this? Yeah, it's all the same base. We have 4 terms here. Every one of them has a log in it. So let's just start condensing this. Over here I have 2 logs subtracted, so the base is the same, we can combine them. When you're subtracting, how do you put them together? Divide, so x minus 1 over x plus 6. Alright, over here again, same base, so we can combine them. They're subtracted, so we divide x minus 2 over x plus 3. Alright, I'm down to 1 log on each side of the equation. So what can we do? Yeah, we can just drop those logs off. So to solve from here, I'm just going to cross multiply. I have to FOIL. Nice thing is though, when I subtract my x squared, it cancels, so it's no longer even a quadratic. So I'll just subtract over my 2x, add over the 12. So if the log is on each side, you can drop them. If it's only on one, we have to change to exponential. On all of these, we need to check at the end. We get 9 over 2 or 4.5. 4.5 minus 1 is positive, plus 6 minus 2 plus 3, all of those are positives, so this does work. Questions? Do you guys want me to work more examples, or do you want to start trying on your own and asking questions while we've got a little time? Yeah. So why don't I go ahead and give you the homework? You can work on that. I'm going to do the same as I did yesterday. I'm going to give you odd problems so you can check them. But I'm giving you time right now to ask questions because I know we haven't worked tons of examples. Like I said, Monday we will do some more practice with this stuff as